Cruise ships are monumental vessels, often referred to as floating cities due to their immense size. Their length can span the equivalent of multiple football fields, showcasing their vast horizontal footprint. Vertically, these ships can rival the height of skyscrapers, featuring many decks above the waterline. This scale allows for extensive amenities, accommodating thousands of passengers and crew in a self-contained environment. Cruise ship construction demands highly specialized shipyards. These facilities are engineered to handle vessels of extraordinary dimensions. Their infrastructure includes massive dry docks and gantry cranes. Such capacity is essential for assembling large, complex ship sections. These specialized shipyards far exceed the capabilities for typical vessel sizes. They are critical for the intricate process of building modern cruise ships. The construction of the world's largest cruise ships is a highly specialized industry. Prominent global shipbuilders lead this sector, demonstrating advanced engineering capabilities. Companies like Fincantieri are renowned for their significant contributions to this field. Meyer-Werft is another key player, recognized for its expertise in large vessel construction. Chantiers de l'Atlantique also stands out, showcasing global leadership in cruise ship building. A shipyard operates as a vast industrial complex, akin to a city dedicated to maritime construction. It employs thousands of skilled professionals, forming a diverse workforce. This workforce includes engineers, welders, electricians, and designers. All personnel collaborate intensively on singular, large-scale shipbuilding projects. The construction of a single cruise ship is a monumental undertaking. This complex process typically spans an extensive period of 2 to 3 years. It necessitates meticulous planning and coordination across various specialized teams. Significant labor resources are allocated throughout the design, fabrication, and assembly phases. The extensive timeline reflects the vast resources and intricate effort required for completion. Cruise ships are complex vessels, not constructed as a single, continuous structure. Their construction utilizes a method known as modular construction. This process involves assembling the ship from numerous prefabricated components. These components are typically giant steel blocks, manufactured off-site. Hundreds of these blocks are then transported and integrated at the shipyard. Modular construction streamlines the building process, enhancing efficiency and precision. Each ship block is a fundamental component in maritime construction. These pre-assembled units are designed for integration into larger vessel structures. Individual blocks can weigh significantly, ranging from 300 to 800 tons. This substantial weight underscores the massive scale of modern shipbuilding components. Colossal blocks are manufactured indoors within expansive workshops. This indoor environment provides optimal conditions for precision work. It ensures protection from adverse external elements like weather. Controlled indoor settings are crucial for maintaining quality standards. Such fabrication methods enhance efficiency and product integrity. Steel plates serve as the fundamental raw material in fabrication. Advanced automated plasma cutters are utilized for precise material processing. This technology ensures high accuracy during the cutting of steel plates. Automated cutting significantly enhances efficiency in the initial fabrication stages. Robotic welding is employed in construction for joining structural beams within building blocks. This advanced automation ensures high consistency in every weld, minimizing human error. The precision of robotic systems significantly enhances the structural strength of connections. Robots operate at increased speeds, accelerating the overall assembly process of structures. The integration of robotic welding optimizes construction efficiency and structural integrity. Essential systems are installed within each ship block during the pre-assembly phase. This process occurs in a workshop environment prior to final integration into the main ship structure. Key components include pipes, cables, and ventilation systems. Pre-installation optimizes efficiency and accessibility for complex system integration. This modular approach streamlines the overall shipbuilding process. Modular construction involves manufacturing building components off-site in a controlled environment. This method significantly enhances overall construction efficiency. It allows for multiple work streams to proceed in parallel, reducing project timelines. Precision is greatly improved due to the controlled factory setting. Components are assembled with high accuracy, minimizing errors and waste. The controlled environment also ensures consistent quality and adherence to standards. Upon completion of fabrication, massive ship blocks are ready for transport. These colossal structures are carefully lifted from the workshops. Giant cranes are employed for this critical, heavy lifting operation. The blocks are then precisely transported to the dry dock area. In the dry dock, they await integration into the emerging ship hull. This process is a vital step in modern shipbuilding assembly. Ship assembly takes place in a dry dock, a specialized basin that can be flooded or drained. The vessel gradually takes shape through the meticulous positioning and joining of prefabricated blocks. These large sections are carefully maneuvered and connected, forming the ship's structure. The process resembles assembling a complex three-dimensional puzzle, requiring precision and coordination. The keel laying ceremony marks the official start of a ship's construction. This event symbolizes the beginning of the vessel's life and its journey to completion. It involves placing the first modular block of the ship's hull in the dry dock. Traditionally, a coin is placed under the keel for good luck and safe passage. The ceremony is a significant milestone in shipbuilding, celebrated by builders and owners. The keel serves as the foundational backbone of a ship. It is a crucial structural component running along the bottom of the hull. The keel provides essential structural integrity to the entire vessel. It acts as the central base upon which the ship's framework is constructed. This fundamental element ensures the ship's strength and stability in water. Ship construction enters an accelerated phase once the first major block is positioned in the dry dock. This initial block serves as the foundational element, marking a critical milestone in the shipbuilding process. Following this, subsequent blocks are integrated at a rapid pace. New sections are often added every few days, significantly expanding the vessel's structure. This method ensures efficient and swift assembly, optimizing the overall construction timeline. The initial phase of shipbuilding begins with the keel laying, marking the start of construction. Within months, individual steel plates are assembled to form the ship's structural framework. This rapid assembly leads to the emergence of a recognizable hull, towering above the dry dock. The visible progress demonstrates the efficiency and scale of modern shipbuilding techniques. After the lower hull is completed, the construction of a modern cruise ship proceeds to the next phase. This stage involves the systematic stacking of upper decks onto the foundational hull. Each deck is meticulously positioned and secured, forming the ship's multi-story superstructure. This process is crucial for creating the characteristic verticality and spaciousness of cruise vessels. The systematic stacking ensures structural integrity and proper integration of all ship components. Cruise ships are massive vessels, often compared to floating cities due to their extensive facilities. A key characteristic of these ships is their multi-deck structure, providing vast internal space. Modern cruise ships typically feature between 15 to 20 decks, stacked vertically. This vertical complexity is comparable to that of a small apartment building. The numerous decks accommodate diverse amenities, enhancing the passenger experience. Engine rooms are critical components within a ship's hull, housing essential machinery. These spaces are designed to accommodate highly complex power generation units. The primary function of these units is to generate power for the entire vessel. Installation involves precise placement and connection of intricate systems. These systems ensure the ship's propulsion, electrical supply, and operational functions. The engine room's design prioritizes efficiency, safety, and accessibility for maintenance. Ships require extensive fuel systems to support long voyages. These systems are integrated to store massive quantities of fuel efficiently. The stored fuel is critical for powering the ship's engines. Fuel supply must be continuous and reliable for sustained operation. The integration ensures consistent fuel delivery throughout the journey. Freshwater production plants are essential for ensuring a potable water supply. These plants are specifically designed to desalinate seawater. Desalination removes salt and impurities, making seawater safe for consumption. This process guarantees a continuous and ample supply of fresh water for all onboard needs. Advanced waste treatment systems are essential for managing waste generated on board. These systems are designed to process all types of waste effectively. Their operation strictly adheres to environmental regulations. This ensures responsible waste disposal and minimizes ecological impact. Stabilizers are critical components fitted to ships to enhance maritime stability. Their primary function is to actively reduce the vessel's rolling motion. This reduction is particularly effective when the ship navigates through rough seas. By minimizing roll, stabilizers significantly improve passenger comfort during voyages. Ultimately, The installation of stabilizers contributes to increased safety for all aboard. Modern cruise ships are recognized as engineering masterpieces. Their sophisticated design is crucial for navigating powerful oceanic forces. These vessels are engineered to withstand extreme marine conditions. Simultaneously, they integrate luxurious amenities for passengers. This dual functionality highlights advanced maritime engineering. The design balances structural integrity with passenger comfort and luxury. Cruise ships are engineered for robust construction, ensuring stability and safety at sea. Despite their inherent durability, these vessels are meticulously designed for passenger comfort. The interior design aims to replicate the luxurious experience found in high-end hotels. This includes a wide array of amenities, such as fine dining, entertainment, and recreational facilities. Every detail is considered to blend the ship's structural integrity with opulent living spaces. The goal is to provide a seamless fusion of maritime engineering and hotel-level luxury for guests. Cruise ships function as self-contained floating power plants. They generate all the electricity required for their extensive operation. This self-sufficiency meets the vast energy demands of the entire vessel. The onboard power generation ensures continuous operation and passenger comfort. Most large cruise ships rely on diesel-electric engines for propulsion and power generation. These systems are highly efficient, meeting the substantial electrical demands of modern vessels. Diesel generators produce electricity, which then powers electric motors connected to the propellers. This configuration allows for flexible power distribution throughout the ship's various systems. It also provides enhanced maneuverability and redundancy compared to direct drive systems. The efficiency of these engines contributes to reduced fuel consumption and operational costs. Diesel-electric engines operate indirectly, not directly driving propellers. Instead, these engines generate electricity, acting as power generators. This generated electricity then powers electric propulsion motors. This system offers enhanced flexibility and improved operational efficiency. Generated electricity is crucial for powering a vast array of ship systems. This power supports essential functions, including the ship's propulsion system. It also supplies energy for onboard amenities such as lighting and kitchen facilities. Furthermore, electricity drives comfort systems like elevators and air conditioning. Entertainment systems also rely on this generated power, ensuring passenger comfort and engagement. Modern cruise ships possess highly advanced onboard power generation systems. These systems are designed to meet the extensive electrical demands of the vessel. The power output of a single cruise ship can be comparable to that of a small town. This illustrates the immense capacity and engineering sophistication of their power plants. Azimuth thrusters are propulsion units that can rotate 360 degrees around a vertical axis. This rotational capability provides ships with exceptional maneuverability in various operational scenarios. Unlike traditional propellers, azimuth thrusters can direct thrust in any direction. This allows for precise control over a vessel's movement, including sideways motion and rotation. The enhanced maneuverability often eliminates the need for tugboats during docking and undocking procedures. This technology significantly improves operational efficiency and reduces port turnaround times for large vessels. After the structural framework of a vessel is complete, the next phase begins. This stage involves the installation and integration of all core operational systems. Once functional, the ship undergoes a comprehensive luxury transformation. This process converts the vessel from a functional structure into a sophisticated environment. The objective is to create a high-end floating hotel experience. This transformation emphasizes aesthetics, comfort, and advanced amenities for guests. The installation of cabins is a critical phase in constructing passenger vessels or accommodations. Thousands of individual cabins are meticulously assembled and fitted into designated spaces. Each cabin is designed to provide private and comfortable accommodations for passengers. This process requires precision engineering and skilled labor to ensure structural integrity. The efficient installation of cabins is vital for maximizing capacity and passenger experience. Each cabin requires comprehensive utility integration to ensure guest comfort and functionality. This process involves the careful installation of plumbing systems for water supply and waste removal. Electrical wiring is meticulously integrated to power lighting, appliances, and other electronic needs. Insulation is crucial for maintaining optimal indoor temperatures and energy efficiency. Essential furniture pieces are strategically placed to maximize space and enhance the living experience. Together, These integrated elements provide all necessary amenities for a comfortable stay. Each cabin is equipped with essential safety systems. These systems are crucial for ensuring passenger security and well-being. Key components include advanced fire detection mechanisms. Integrated fire suppression systems are also in place to mitigate risks effectively. Extensive public areas are meticulously constructed to cater to diverse recreational needs. These facilities include a variety of dining options, such as restaurants, offering culinary experiences. Entertainment venues like theaters and casinos are integrated to provide leisure and amusement. Recreational amenities such as swimming pools and water slides are also built, enhancing leisure activities. Modern transportation hubs are increasingly integrating diverse recreational facilities to enhance passenger experience. These facilities are designed to cater to the wellness and leisure needs of travelers during their journeys. Examples include state-of-the-art gyms, providing opportunities for physical activity and stress reduction. Additionally, luxurious spas offer relaxation and rejuvenation services, promoting overall well-being. The development of these amenities reflects a growing focus on passenger comfort and holistic travel experiences. Modern cruise ships offer highly specialized attractions to enhance the onboard experience. These unique features push the boundaries of traditional maritime entertainment. Examples include ice skating rinks, surf simulators, and even full-scale roller coasters. Such innovations transform cruise ships into floating entertainment complexes. Efficient passenger flow design is crucial for managing large crowds in complex environments. Design teams meticulously plan routes and spaces to optimize movement. The primary goal is to prevent congestion and ensure smooth transit for all individuals. This design principle is vital in venues like cruise ships, airports, and large public spaces. It ensures thousands of guests can navigate the environment safely and efficiently. Safety at sea is an absolute and paramount priority for all maritime operation. This priority necessitates strict adherence to comprehensive fire safety regulation. All interior installations on vessels must comply with these rigorous standards. These regulations are designed to prevent fires and protect lives and property. Compliance ensures the highest level of safety for everyone on board. Upon the completion of the ship's exterior structure, a crucial phase of construction begins. The dry dock, where the vessel was built, is systematically flooded with water. This controlled flooding allows the newly constructed ship to achieve buoyancy and float for the first time. This event marks a significant milestone in the shipbuilding process, transitioning from dry construction to waterborne readiness. The float-out event marks a critical milestone in shipbuilding. It signifies the ship's readiness to depart the dry dock. This transition allows the vessel to proceed to subsequent construction phases. The event is a key indicator of progress in the ship's development. Following its initial float-out, the ship is maneuvered to an outfitting dock. This stage marks the beginning of extensive interior construction and finishing work. The focus is on completing all passenger and crew spaces within the vessel. This intricate process typically spans several months to ensure all details are finalized. Before final delivery, every cruise ship undergoes rigorous sea trials. These trials assess operational capabilities and safety features. Testing occurs under real-world conditions to ensure peak performance. This critical phase confirms the vessel meets all design and safety standards. Engineers conduct comprehensive performance tests on the ship. These tests evaluate critical aspects, including speed and steering capabilities. Emergency systems and stabilizers are rigorously assessed for reliability. Power output is measured to ensure optimal operational efficiency. The ship is pushed to its operational limits to verify its full potential and safety. Emergency scenario simulations are conducted to test system effectiveness. These simulations ensure that all critical systems function reliably under pressure. They also evaluate the efficiency and responsiveness of crew actions. The goal is to enhance preparedness and optimize responses in real critical situations. Sea trials are critical evaluations of a ship's performance and systems before delivery. Any issues or deficiencies identified during these trials must be addressed immediately. Prompt rectification is essential to ensure the vessel meets all operational standards. The ship cannot be officially handed over to the cruise line until all issues are resolved. The official delivery of a cruise ship marks the culmination of extensive design and construction efforts. This critical phase follows the successful completion of rigorous sea trials. Sea trials ensure the vessel meets all performance, safety, and operational standards. After trials, final preparations are made, addressing any adjustments or enhancements. The ship is then formally handed over to the purchasing cruise line, such as Royal Caribbean International. This delivery concludes years of intricate work, transitioning the vessel from shipyard to service.